This video is a continuation of the previous video on Unit 1 Kinematics for AP Mechanics. Here we have a boat which is traveling across a river with a current as shown in the figure. And there are two velocities given to us, VB and VC. VB is relative to water. So VB is equal to 4 meter per second. And VC is given to us as 3 meter per second. Now, before we write relative to what or with respect to what the velocity is given, let's just fix B for boat, C for current or water, and S for shore. So VBC, that is boat's velocity with respect to water, that is the current, is given as 4 meter per second. VCS, that is the velocity of current with respect to shore, is given as 3 meter per second. Now we want to find velocity of boat relative to shore. So we can write VBS is equal to VBC plus VCS using the concept of relative motion. Now, because velocity is a vector quantity and we cannot just add them directly, we have to look at their directions, and we can see that VBC and VCS, as you can see in the diagram, they are moving at a 90-degree angle. That means the directions are making a 90-degree angle with each other. That means we'll use Pythagoras theorem to find what is the velocity. So VBS will be square root of VBC square plus VCS square. Substitute the numbers and we get the answer as 5 meter per second. Students testing two different toy cars on a straight track determine that starting from rest, car A reaches velocity VA in displacement XA and car B reaches a velocity of 2 VA in displacement 2XA. So we can just get this information separately for car A and car B. The acceleration of car A is given as AA. We want to find what's the acceleration of car B. Now we have this kinematic equation Vf square equal to Vi square plus 2A delta x. We can see that they are starting from rest, so Vi will become 0, and we can rearrange the equation for acceleration because that's what we want to find. Now for A, that is car A, we can write VA square over 2XA. And for acceleration of B, we know that it's twice the velocity and twice the distance or displacement. So we can substitute that into the equation. Open up the top bracket. So 2 square will be 4 VA square. We can see that 4 and 2 can be cancelled and you will be left with 2 VA square over 2XA. Now, if you compare AA and AB, that is acceleration of car A and acceleration of car B, we'll see that this 2 is an extra factor. Everything else is same. That means our answer is C, that is acceleration of B is 2 times the acceleration of A. Next, we have got again a projectile motion problem. Here, we want to find what is true regarding point P. P is the highest point in its motion. So we know that the components of the initial velocity is V0 cosine theta and V0 sine theta. Horizontal speed remains constant. At the maximum height, vertical speed will be equal to 0. So we know that at point P, vertical speed will be equal to 0. And magnitude of acceleration will be G. We are not writing it as minus G because it's talking about magnitude. So our correct option will be B, which says horizontal speed is V0 cosine theta, which does not change. Vertical speed is 0 and magnitude of acceleration is G. Next, a car starting from rest accelerates at a constant 1 meter per second square. Accelerates at this value. That means that's the value for acceleration. And it's starting from rest, so Vi is equal to 0. The time is 3 seconds. Now, if the car continues moving for 5 seconds at a constant velocity, how far the car traveled from its starting point? So we want to visualize it. Let's say the car started from point A, from rest, and reaches to point B in 3 seconds. Then from B to C, it's going to travel with constant velocity for 5 seconds. So first we have to find what was its velocity at point B, because from A to B it accelerated. So we can use Vf equal Vi plus AT. Vi is 0, acceleration is 1, time is 3. So we know that the velocity at point B will be 3 meter per second. Now we know that from B to C, it is traveling at constant velocity. That means for B to C, the velocity will be 3 meter per second. And we can find the distance because it's not accelerating between B and C. So we can use the usual formula for distance, which is speed multiplied by time. So you'll get 3 times 5 equal to 15 meter. Now from A to B, it is accelerating. So we'll use the kinematic equations. Delta x equal to VIT plus half AT square. We can substitute the numbers which we have got. Initially it was at rest. Acceleration is 1, time is 3, and we will get that as 4.5. So the total will be 19.5 meter.